In this video, we'll be taking a fairly comprehensive look at dynamics processes and the dynamic processors inside of Bitwig Studio. But for the most part, these concepts are universal. And so what you maybe learn in this video, you'll hopefully be able to apply inside of any digital audio workstation or working with different plugins. The reason I'm deciding to make this video now is like twofold. One is we now have the ability to increase the interface size. And so some of these dynamic processors that I covered in the past didn't used to have the nice like visual tracer. It didn't have all the visual feedback that they do now. So maybe some of the things I talked about in the past were a bit confusing. We should be able to really hammer those out here. And secondly, I want to put all of this information into one video. So it's probably going to be pretty long, but hopefully you can come back, use the time markers whenever you're confused about a particular dynamics process. You'll be able to see that here and be good to go. All right, so without further ado, let's jump into it. Let's begin by talking about gating, also known as downwards expansion, also known as simply fading the sound out. So when the sound goes below a threshold, it either cuts off abruptly or it cuts off on some kind of like slope. And so if you think about it, you actually do gating or downwards expansion every day. You just don't normally use an effect for it. So the effect is typically when you need something a bit more drastic. So here we have this snare sound. And if I wanted to gate this, if I wanted to cut this off, I could just take the clip and I could pull it back. So if I don't want that fade at the end, I could just cut off my sound like this. And this is something you guys do every day when you're making music, right? Conversely, I could go in at the event level and I could do some like a gain automation. And this is actually often what I end up doing. So let's say that we want it to kind of like cut off at this point, but we don't want it to be so abrupt, and we don't maybe want to use the auto fade. In the past with Bitwig, we didn't have fades. So now we do, and we could just bring a fade in. But what I used to do a lot of times would be to go in here and cut it off, and then I have a lot of control over this curve, and you could get something really nice, get a lot of variation. So if, for example, and you could compare that to if you were to cut it off. But again, like I said, now we do have the fades. And so it's really easy to work with this. But that is, in essence, gating. And the way you could think about it with the effect would be we set the threshold up. And let's say that this is like -20, this point here. Obviously, this sound is decaying away. So when it goes below that -20, it speeds up the process of decaying or taking away. And I can show this to you with the actual gate effect itself. Pretty easy to understand here. And so just to explain this to you, we can take the threshold, we can bring this to -20 like I was just saying. Depth is determining by how much is it going to cut it off. So in this case, we're going to cut it off by 120 dB. That's the equivalence of silence. Now we listen. When it goes to below 20, it's going to cut the sound off. So, and you can hear that like so. And then we can adjust how abrupt that cutoff is. We can give it more of like a little bit longer of a length here. And then if we don't want it going to silence, if instead we only want it dropping by like 5 dB, this is going to be an interesting effect. We could do something like that. So you get this whole little different curve going there. Again, would it be easier to just go in and draw that in yourself? It probably would be, but... And so the last thing to talk about is the attack. And the attack determines at what point is the gate going to open up. Is it going to open up immediately, or is it going to take some time? And in this case, it's going to take a bit of time. Notice, though, that this control is insanely quick. Even at the highest setting, this is only 100 milliseconds. If we put it at 100 milliseconds, we're going to hear that we kind of remove some of the transient here. You can really hear that transient popping through compared to having the gate come open immediately. And now we still have all of that transient energy happening there. So the threshold becomes very important. Depth becomes very important. Again, let's go extreme with it. Compared to, you can see how long it's taking for that gate to reopen. Or So really the most important setting is threshold, and you'll see that as you go down lower in threshold, it really struggles to detect this, and you'll get kind of like a strange glitch happening. In this case, it's done a very good job. Let's actually go just to that point. So we bring in the quick release. You can hear that it's really struggling to kind of do this in more of a linear fashion. So there are times in situations where just kind of doing this manually is going to work out a lot better for you. Just to further explain this gate analogy, why this is called a gate, the way we can think about it is if I go all the way to the top with the threshold here, this is basically saying, okay, no matter how loud the signal is, we are going to keep the gate closed. No sound is going to leak through this gate at all. It's coming in, it's smashing into the gate, and it's not letting anything through. You shall not pass, right? We're getting no sound at all. Conversely, if we take the threshold all the way to minus infinity, the gate is wide open at all times. And no matter what we set these other parameters to, it's not going to make a difference. The sound is just rushing through. All right. And so what we really are doing is something in the middle. We're saying, okay, we're going to let this much through, but once the sound starts to get a bit quieter, we're going to slam that gate, and then we determine how that gate slams. Does it slam closely? You know, you're gently closing the door, or are you smashing it closed? So just so you can hear that. You can hear there are certain places where it's going to have trouble doing that. Here it's actually doing pretty well. The more release we put on, the better it's going to be able to handle this, because really it's hard to slam something in real time, right? You can't slam a door in 0 seconds. Something like that is going to sound very smooth, and you can even then see what's going on there in the little display area that we have here. Okay, so that's gating. Let's talk about one application where gating is actually very useful and where you kind of can't go in and draw it in unless you go through several steps. The classic pairing in music production for a gate is when you have some kind of a reverb and you want to cut that reverb off with the actual signal itself. So in this case, signal flow really does matter, and it makes a huge difference, because if we have the gate before the reverb, obviously it's not going to cut off, right? But it does have some cool effects and some advantages to it. So let's listen to what we have now, and then let's listen to what happens when we bring the gate in. You can kind of hear that it adds a little bit of a bounce to it because we're cutting off the signal. So that in itself is actually kind of a cool effect in the situation where you may bring the gate in front. But at the same time, you could just go in here and like manually gate this sound by taking the clip and pulling it back. So what you tend to do is you go in here with the gate, you bring it post reverb, and now you have just kind of that one sound, and you're able to cut it off. So and I might add a little bit of a release characteristic to this. So this would probably work pretty well. And now when the reverb is off, you can hear when we bring that in, we get that characteristic of the reverb without the really long decay that we have going on here. One other thing you can actually do, and this is the way I do tend to work most of the time, I don't really like fiddling with gates, because let's say that you have a lot of like velocity variation. The gate is going to then respond like quite a bit differently. And sometimes you'll get some of those errors, like you see some of those spikes occurring. So what I tend to do, and again, I'm not really encouraging that you do it this way. Sometimes people just want to see the way I do things. What I would do is I'd actually take the mix on the reverb all the way up to 100%. I would then go in and I would like consolidate this here. Go in at the event level, bring this back to whatever I wanted. Okay, let's imagine that that's the sound there. And then I would take it and I would bounce it. So now this is just the reverb, obviously. And then what I could do is I could get rid of the actual reverb on the signal, and we would probably put these into like a group of some kind, call this the snare. And now I have control over the reverb and the snare. So when we play it back, And now what can I do? Well, I can go in here and I can gate it. And then if I wanted to go even further, I could use my gain control and I could further shape this. And I could even take it and I could like shape it up if I wanted to do that. We could get kind of a really interesting effect on this. This would be like upwards expansion. So you can do that. Obviously, these are grouped together. If we wanted to go really far with it and go crazy with it, we could go and we could actually bounce these together. We could bounce the group. That could be our snare sound. And then from there, with that signal, you obviously can go in. And if you want to get those gain variations, you can go and do it from here. So you could still get that like supposed velocity variation without ever having to worry about the gate responding in a weird or funky way. So that is gating, easiest to understand of all of your dynamic processes. And in many situations, in almost every situation, it makes more sense to go in and kind of do it manually, as you've seen me do here. And obviously, it's very powerful. You can get a lot of variation this way. Just so you guys can see it, this would be downwards expansion inside of the dynamics effect. But notice that the ratio only goes down to 2:1. As compared to the gate, you could actually almost imagine this like a straight line down, kind of like a brick wall. Like the gate itself is actually completely shut and cutting off the signal. So here, especially when we add in things like the knee control, we can get a little bit more of like a smooth fading out effect. All right, without having to bounce it and do that ourselves. So here with the reverb, we can just experiment with the settings. You can see how it cuts it off. And it does so in a really nice way. So if I turn the reverb off and I bring it back on, and you might ask, well, why don't you just like change the time on the reverb, like bring that decay time down? The sound itself is actually going to be a little bit different. Okay, and part of this also then has to do with the signal that's coming through in the first place. So I'm just going to go in here and bring this attack all the way down. And we're going to change this threshold point, have it cut off sooner. We can then adjust the release. Again, too fast and you get those sort of effects. A little bit longer and you get that. And then we have the knee control, which is going to round this off and make it even smoother. And you can see how that slope changes. So I definitely like working with the dynamics as well. But remember, this isn't really like a full-blown gate. This is a little bit more of just a classic downwards expansion where you're getting that nice smooth sort of decay. And in this case, I would argue that if you did have a lot of velocity variation, you won't have too many problems with this. It should sound smooth regardless, especially if you're doing something kind of broad and sweeping like this. It's always going to just give you that nice little smooth decay. And you can see that like so, and we can really smooth it out here as compared to it's probably also worth noting, at least in passing, that when you use the transient control and you take the gain for the sustain and you bring it all the way down, that this is now going to react very similarly to a gate also. You can adjust the time. Again, if you go too fast, it struggles. But again, you may not typically be going all the way by 200%. You may just want this to be down by a little bit. And then that's really kind of where you get your smoothing characteristics. So one thing you can then do in conjunction is you could bring up the attack to try to compensate out a little bit here. And we now have a totally different sounding snare than we did at the start. So always more than one way to skin a cat. Just figured I would show you that the transient control can also work similar to a gate. And this also then works as a nice little preview to what we'll be looking at with upwards expansion. I think it's really important to understand that with dynamics processing, there's always more than one way to skin a cat. You can get the same result using very different processes, and that's going to be a theme that you see henceforth running through the following examples and different types of processes. So the next thing we're going to look at is upwards expansion, and upwards expansion is the inverse of downwards expansion. When the signal crosses above a certain threshold, it actually boosts it and makes it louder. So this is very similar to something like a transient designer that's actually taking the front part of the signal and boosting it up. The inverse of that is compression, where if you have like a slow attack time, you can cut off what happens underneath it and then boost the overall gain up. But just to show you a couple examples here of upwards expansion, we'll start again at the event level. I can go in here and I can add a boost at the start of this and really emphasize the transient in a particular way. So for example, we actually should listen to a before, shouldn't we? I can go in here and do something like this. That's very snappy, so maybe something like that works better. And again, I have control over these fades, and I can get all sorts of different options. This is very similar to what happens with a transient designer, only here you're going in and you're doing it manually. So let's go and use the dynamics effect next and show you how you would set that up. The dynamics effect is great because it gives us the visual feedback and lets us see exactly what we're doing to the signal. So if we wanted to do more of an upwards expansion, what we would do is take this ratio control and move it to the left. And so what this is showing us is that when the signal crosses the threshold, it's going to jump up and get louder. Again, remember here with the ratio, though, we can only go 2 to 1, as compared to if we go the traditional direction, we can go kind of as aggressive as we want with our compression. But here with the upwards expansion, it's not going to let us go too crazy with it. If we really want to go crazy with it, we'd have to go in there and do it manually. Obviously, we're not working off any kind of ratio in that case. And again, we have a knee control, so we can do something smoothing or something a bit more aggressive. And here we're going to do something a bit more aggressive. So I'm even going to go in here and at the beginning, take this and bring it down even further because this can get out of hand really, really quickly. So we're going to bring this down, and now let's go in and let's try this out a little bit. Turn off the dynamics so you can hear the before. And we're really going to be listening to what happens at that transient point. Maybe we should even cut this off a bit. Cool. Okay, so we bring this up. At this point, we're not crossing threshold at all. We'll bring that down so that when it goes over, it's going to get louder now. And you can see the shape of that here. But at this point, it's kind of acting over the whole signal. So we need to bring our release time down to try to just focus in on that transient. All right, so let's take a listen with it off, with it on. You can hear that smack we're getting. And here's where we're going to see a huge difference in the meters, okay? This is with the dynamics turned off. Minus 15 with it turned on. You can see how much it's jumping up there at that peak point. And then again, if we want something a little smoother, we can use the knee control. There's a lot of variation you can get. Hey-yo. Really get that smacking. And that's really the basis for upwards expansion. So I'll also show you how you achieve the similar effect using the transient designer, transient control. So last but not least, we have the transient control. And in this case, what we can do is we can focus it in on the attack, and we can determine how long that time is going to be. So for example, with this signal, if I go in here and start to increase the gain, we can then determine for how long we want that to happen. So I could bring this way down, and this should just be getting the initial snap at the beginning. And you can really hear the snap it gives you. And this is making a huge difference, over almost 10 dB. But it sounds pretty clean and pretty smooth because that's exactly what this thing is designed to do. All right, that's something I need to really kind of stress. There's a reason why you go to the transient control on transient signals. It's going to kind of maybe sound the cleanest. That may not always be what you're going for. We also have the detection option where with the RMS, it's going to smooth this out by quite a bit. You can see that shape smoothing it. Compared to, this is going to be really aggressive. Right, you can see that like so. But maybe we want this to be smoother. We would increase the time here. So that's maybe not quite as aggressive. Something like that maybe. And again, we can do a compare and contrast at the end. And then we can obviously set a mix balance between these so we can give it just a little more pop. And we'd probably want some kind of a additional like tool device or something to then match gain at the end. But that's the general idea with upwards expansion. The next dynamic process we're going to look at is upwards compression. So this is actually fairly rare to find in plugins. Bitwig is capable of it. Anything that attempts to really maximize loudness is probably going to have some form of upwards compression built into it. And in a little while, you'll see why this is so useful for really bringing up the loudness. But just so you can see what upwards compression is, the way it works is when the signal falls below a threshold point, it then brings the signal up. And so you saw me do this a little bit earlier when I was like, hey, we could bring up the end of this reverb tail a little bit. That's something that upwards compression is capable of. When the signal falls below a threshold, it turns things up. And so this is an inverse of what you have with downwards compression, where when the signal is too loud, it turns things down. And that, of course, reduces dynamic range. The same thing can be said about upwards compression depending on how you set it up. So we could have a threshold point like around here and immediately jack this signal up. And so it almost like levels this out. Less peak energy and the perceived loudness is going to increase. But this is the general idea with upwards compression. And so we'll try to emulate this sort of a sound using a couple of different effects that are capable of doing this. First things first, we have the dynamics. So whenever we take the ratio control on the low threshold area and move it to the right, this is exactly what we're doing. When the signal falls below the threshold, it's going to turn things up. All right, so let's go ahead here and experiment with this. So in this situation, our threshold is set too low. So by the time it starts to turn things up, it's almost at the end and it makes very little difference. You can hear right there at the end, it starts to get louder. But as I bring this up further, and in this case, let's go drastic with the knee, you can hear the effect it's getting. The attack is actually making this take a little bit too long to kick in. I want it to kick in immediately after it falls below threshold, so I'll just bring that right down. And then release time is how fast it's going to jump up. So that's maybe too fast. Still too fast. But we can go in here and experiment now with the knee. Also notice that this ratio can be set very high. It can actually go into like limiter settings. So instead of like downward limiting, it's upward limiting. Very cool concept. Very extreme. So we're basically just having it bypass that initial peak and then start to kick up. And we could slow that down further. So that's a very interesting effect. And in this case, it seems very drastic. But when I play it on a drum loop, you'll start to understand how this can be used to bring up perceived loudness. Because remember, we're not touching the peak at all. The peak is still the peak. So if I have this turned off, okay, we'll be able to see this. And maybe this is going to be too extreme with the ratio setting I have. But this is the peak value, -9. With this turned on, changes a little bit. But I could obviously compensate for that here, and it's still going to perceptually sound a heck of a lot louder. Right, like so. As I've mentioned before, it makes sense to use devices that really partner well with the signals you're working with. So in this case, we have a snare. It's a drum hit. It's a transient sound. The transient controller is going to make a lot of sense for our upwards compression in this example. And so you can see that the way I would set this up is to actually go to the sustain, and I'd want to bring the gain up on that, all right? And then time determines kind of how quick that's going to kick in and how close it's going to set it to the actual transient. So it's possible that we could actually grab a part of this signal, like let's say here, and bring it up louder than the transient. That's why you're going to see, you know, that gain mismatch there on the peak level. So let's just go ahead and do that. And one thing that I've noticed is that if you use RMS, it does help to smooth this out. So again, we're having almost a dB of difference. If I bring that time up a little bit more, it won't be by quite as much. And then again, we might go in here and use the mix control to get a little bit more of that decay if that's something that we wanted to do. So the transient controller works great for upwards compression on individual sounds, but it can also actually be used on things like loops. And so we'll be doing one more example where we do some upwards compression to bring up our perceived loudness. Here we have just a standard drum loop. And we can see that there is quite a difference between the peakiest sounds and some of those quieter hi-hat hits, especially as they decay away. So what we could do is we could use a form of upwards compression so that every time after the peak hits, we bring up the signal a little bit. So again, we're not trying to in any way like touch the peak. We're just trying to bring everything else up to sort of match it. And so the peak value isn't going to be any higher, but the perceived loudness certainly will be. All right, so let's experiment with that a little bit. We'll start with the transient controller and then use the dynamics effect. We can get a very similar result here. In this case, we've brought up the gain quite a bit. So it's at a point where the peaks are almost sounding quieter than all this stuff happening afterwards. We can go in here and use RMS, and that usually smooths things out a little bit. You can see it jumping the signal up. So here's our before, and again, we are going really extreme with this. And got local there to increase time. Time for a little upwards compression using the dynamics effect. So we can hear it and see how it keeps bringing the signal out there. And again, let's check what we have here at the output. So we need to bring this down by about 2 dB to make it a fair comparison. All right, this should be a fair comparison now. So maybe it doesn't have quite as much of an impact. You can see you can get a lot of interesting effects with it. But where this really becomes so powerful is when you combine it with your downwards compression. So we could set up something more of like a limiting on the peaks and then also have the upwards compression happening. So you get it from both ends, from the top and from the bottom. And then you can really squash the thing. And that's how you get sort of like that max loudness effect. I think that's actually how the Waves plugin works, is it combines like a peak limiting with an upwards compression. So let's just set that up here quickly just so you can see it. So this is going to now have it turned down probably pretty drastically. And remember that 6 dB is where we're peaking out. So now we actually need to go in and so would you ever really set something up like this? Probably not. Maybe you could set something up like this. And then we can bounce it and take a look at it just so you can see what's going on here. All right. And you'll notice that the difference between the peak and everything else is going to be reduced by quite a bit when we get into this one. So you can see all those different hits comparatively to here, you know, pretty massive difference right there, what we've been able to achieve using our upwards compression. And in this case, we did a hybrid of both upwards compression and then also a bit of downward style limiting. So the last type of dynamics processing we're going to look at is downwards compression. This is what you're probably most familiar with, and for a lot of people, this works as the Swiss Army knife because they may not be aware of the other types of dynamic processing that are out there. They just don't use them. So here, suddenly, attack and release control become really important, mostly just for flexibility. But the fundamental idea is actually very simple. Signal goes above threshold, gets brought down. Okay, so in this example, let's say that we want to reduce the peak level here. I would just go right from the very beginning, super fast attack time, bring that signal down, and then have it come back up. That's what the release time is saying, to the original point. So now when we listen to it, it's just going to sound a lot quieter than it did before. And if we take a look at the peak value has been brought down by roughly 4 dB. So now I could come in here and bring 4 back into it. 1, 2, 3, 4. And perceptually, it should actually now sound louder because we've reduced the difference from the peak to the rest of the signal. And also another sort of perceptual thing with our hearing is that super fast peaks, even if there's a huge difference, you don't really hear it as such. So in a lot of cases, it actually makes sense to go in and reduce the peak energy, mainly just because it's taking up a bunch of headroom for no reason. So that's really the basics of downward compression. And so we'll go ahead and set a few of these examples up, talk about the different types of downward processors, and then also do maybe a little of a compare and contrast as to why does the dynamics effect sound different to the compressor that we have inside of Bitwig. So we'll begin with our handy dandy dynamics effect. And the way to set up your downwards compression is to take the ratio, turn it to the right. So when the signal goes above our threshold, it gets turned down, and it's based on a ratio. So the idea here, you don't even really necessarily need to know this. You just know that the more you go, the more aggressive it's going to clamp that down. So the thing would be when we breach our threshold by 4 dB, what gets outputted is 1 dB. If we breach our threshold by 8 dB, what gets outputted is 1 dB. So it's just a more aggressive clamping down on the signal. So I'll just show you that if we start at like 2 dB, let's set our attack to be immediate so that we're able to actually bring the transient down, leave the release where it's at, and let's just take a listen. So let's take a look here and see. We're outputting at around -9. We're now at about -12. So we can bring this up by roughly 2.5 to compensate. And what you're really listening to is, especially at the end of this signal, the reverb tail, the decay, is sounding a lot more prominent. And obviously we've lost a lot of punch. And that's because we've brought out, really, we've actually turned down basically the entire snare hit here. If we bring the release further back, we'll be able to focus a little bit more in on the transient and really just bring that energy down. And again, if I want to be brought down even further, I can increase the ratio. And again, we can now check and see that what we're peaking out at is about -10, so we can go in here and bring even a whole nother dB in. Compare. So the second version sounds like a bit louder. That's just because everything has been brought back together. The first version sounds obviously a lot more punchy. And then we can use the knee to kind of smooth this out a little bit so that the compression even starts a little bit earlier and the release kind of fades a bit more. You can see with the release curve how this works. So you can get something kind of smooth in there. So it's just kind of about tinkering with it to find what's going to work best. So that's the basics with downward compression. Conversely, again, because this is like a Swiss Army knife, if we want to emphasize the attack portion of the sound, the initial transient hit, we've talked about different ways we could do that by turning things up. Well, we could also kind of do it by turning things down. And so the way to think about that is have a pretty long attack time so that it goes past most of this transient information and then turn down the signal immediately following it to emphasize it even further. So let's go ahead and see if we can set that up here. Okay, so this is about where we need it to be. Even if we increase the release more, just to keep it quiet. So now, compared to, you can really hear that initial part punch through because we're turning down immediately after it. So you really have to know what you're trying to do when you're bringing on any kind of dynamics effect. It's not just like a compressor is going to make something louder, so to speak. And of course, that's such a relative term anyway. But if you know, okay, I want to emphasize the attack, well, you now see that there's a lot of different ways that you could do that. You don't just have to use downwards compression. You could use a variety of different techniques, and you can always go in and just kind of draw the envelope in yourself. The resulting sound is always going to be a little bit different depending on what approach you use. And so that for you as the music producer, as the mix engineer, is what you need to figure out. What sort of effect, what sort of dynamic process is going to get me the sound that I want, that I'm going for. Okay, cool. Let's compare and contrast how the dynamics is working as compared to the compressor. And then also we'll bring in the peak limiter and probably revisit the transient control again, because no surprise, the transient control can also do what the dynamics effect, or I should say the downward compression, can do. With the transient control, this should be pretty straightforward to you by now. If we want to try to bring down the peak, if we have a threshold, we want to bring that down, we'll just go to the attack section and bring down the gain on this. And then determine the time. If we want to just try to get the peak, we can do it like this. And so again, what we can then do is check and see, okay, what was our peak value before? -9. Now we're at -13, so we need to do quite a bit of compensation. And we could actually just put these together. So you can hear how that peak is completely gone. Or conversely, if we were pretending like we had more of like a long attack time, we wouldn't go in and mess with the attack. We'd mess with the sustain, and we'd bring the gain down on sustain. But this is a little bit tricky because it's not going to jump back up for us. All right, so here's an example where it's not the same. Like, it's not going to then rise back up as we had with the downwards compression. This is now acting more of like that gate or that downwards expansion where it's sort of fading things out a little bit. All right, so just some things to be aware of when you're using some of your different dynamic processors, specifically the differences between the classic downwards compression and the transient control. Let's quickly compare the difference between the dynamics effect set up as a peak limiter versus using the actual peak limiter. And the difference has to do with this look ahead control here. So I have this already set up. To turn the dynamics effect from a compressor into a limiter, you just have to change your ratio so that you're going above 10 is typically the point. And you can go all the way to infinity if you want to create that brick wall peak limiter. So anything that goes over threshold is not going to necessarily output any louder. So we're never going to be distorting. That's really the main idea with kind of limiting. And so what we're doing is anytime we cross the threshold, we're clamping down hard. All right, so we take these peaks, clamp down hard, and then add the makeup gain to compensate. So here's a setting I have with the dynamics. Notice, however, that the attack does not go faster than 0.1 millisecond. That's still ridiculously quick, however, and it's not really going to let too much leakage through. Quicker the release, the more bounce you can get. All right, so this is now outputting around minus 5.0. We need to bring it back 1 more dB. Try to make this as fair as possible. Turn it off. So really listen to things like hi-hat and the decay. That really gets heightened because we're crushing down there on the peaks. And you can see that like so. The longer the release time we have, the less it's going to be able to recover. And therefore, you can actually pump like more gain out of it, but you're getting less bounce. So you typically want, especially if it's dance music, anything with drums, you kind of want as much bounce as possible. But just show you that you can see that now it's constantly going. And it just barely recovers. But we get a lot less bounce on it. So with the peak limiter, what we actually have is a similar sort of shape here. But the difference is we don't have an attack setting because the attack is as fast as possible. So it's faster than 0.1 millisecond. And the fact that we have here this option for look ahead, you can see that we've added 1.5 milliseconds. That's like the look ahead, meaning that it's actually scanning the signal in advance so that it will catch every single peak. It's not going to miss anything at all. All right, that's the main point of this. So now when we bring this peak limiter in, we have a ceiling, and that ceiling determines when it's going to start clamping down. So in this case, the maximum value that this is coming out at is like -6. So I can go ahead and just set this to be -6, and then I can start to pump additional gain into it for then it to start to bring down those peak levels. So let's go ahead and do that here. And again, we can then get a lot more bounce. And so it's a smoother effect, obviously. And you can really slam it in here if you want. And if we increase the release, again, we can kind of do what we did before, where it never really fully recovers. It smooths things out, but at the expense of the bounce. It's all about finding a nice midpoint. And the more we drive it in then, you'll see that it starts to clamp down on peaks beyond just like the major ones, right? So then other things are breaching that threshold. At a certain point, it just starts to sound bad. But that's the general idea. That's the real difference between a peak limiter and your dynamics. You'll see that when I remove the peak limiter now and we look at this track, there is no latency that's been applied. So that is what happens when you bring the peak limiter on. That's the look ahead. And it does a better job, obviously. As you can hear. So there are different applications for these things. With certain sounds, you may actually prefer using the dynamics device this way. You may also prefer just using the transient control. So more than one way to skin a cat, just a matter of kind of figuring that out. For the sake of completion, let's talk about the De-Esser. The De-Esser is a frequency-dependent downward style compressor in that it takes the signal, it breaks it up, and it listens to only a particular portion. So in this case, high frequencies. And so we can solo the band and listen to what exactly it's listening to. So let's say we just want to focus in on that super high part of the hi-hat there. And we want to try to bring that down. We just increase the amount. We don't have any attack. We don't have any release. We don't have any ratio control. That's all set up behind closed doors. And so the effect itself doesn't always work that well. And in the real purpose of this is for like S's and vocals. If you have something really sibilant, really S-y, and it's just poking out from the speakers and driving you mad, you can use a de-esser and try to find that place and then bring in the amount to taste. Personally, I don't even use this one to do de-essing on vocals. I don't think it sounds particularly good. I think it was just kind of done rather quickly. Maybe I just am not setting it up properly, but I would prefer, and I'll show you this in a second, going with more of like a multi-band setup, finding that area that you want, really kind of pinpointing it, and then having your dynamics control where you have attack, release, ratio, etc. But for now, this is what it will do. And so you'll hear that when I bring this out and we're able to listen to the whole thing, that portion, those hi-hats are going to be much quieter. We'll exaggerate a little bit more. So you can hear that with a full frequency signal like this, it runs into some trouble. You can actually also just set a blend. If you don't want quite as many highs in the signal. But in this case, the drum loop sounds absolutely fine without it. I just want to show you the de-esser. But we can set up and create our own de-esser with a little bit more functionality, and that's what we're going to be doing next. What I actually prefer to do if I'm going for like a de-essing application is actually more of like a multi-band compressor setup where I'm only applying a compressor to one particular region. So in this case, it's roughly, really 4.5K and up since there's a slope going on here, and we can isolate that region out and then apply compression specifically to that. So if I go into the high band and I add in the dynamics effect, and again, I could actually use anything in this case, I can now apply compression to just this region and get a sound that I'm happy with as compared to what we just saw with the de-esser, where a lot of those controls, we don't really know exactly what's going on. Obviously, it's a super fast attack and a very fast release, but maybe that's not always going to work out the best. So let's say I just want to focus in on this region here. Bring a little bit back in. You can hear just how much smoother that sounds coming out with this sort of a setup. And that's usually the way I like to do it. This Dynamics plugin is really extremely clean. It's very digital, and I mean digital in a good way. It does what you expect it to do without adding in a lot of other sounds, any other artifacts, any distortion or saturation. And that's kind of what we're going to be talking about here to close out this video. A question many people have to Bitwig Studio and to the effects is what's the difference between the dynamics and the compressor? And we can actually read what the difference is. The compressor acts as a feedback topology compressor. All it can do is downwards compression, whereas the dynamics, we can't necessarily assume it's feed forward, but it basically is feed forward because it can react incredibly quick to any signal we give it to, and it's very clean, and it's capable of upwards and downwards compression and expansion, and we've gone through all of those examples so far. So a couple of very quick comparisons here, some things that are obvious, at least to the eye, is that the attack time on the dynamics can get all the way down to 0.1 millisecond. The attack time on this feedback topology compressor can get down to 0.2, and that actually does just have to do with the design of the compressors. A feedback compressor can still go really quick, but it can never go as quick as something feed forward. All right, that's just based on the design. And so in the computer, that's not all that important, and it's really not that important to understand the difference between feedback and feed forward. What I would say is important is to understand the saturation that's brought in with these different dynamics effects, and I'll let you see that here in just a second. In my opinion, the real main difference between the dynamics device and the compressor has to do with the bulk and the heft of what's generated when you are compressing. Because remember, like analog versus digital design, in an analog design, even with compression, you're kind of are having to overdrive an amplifier and then bring the signal down. And when you overdrive anything, you introduce some kind of a distortion. In the digital domain, that doesn't necessarily have to happen. So we actually have a test tone coming in right now. And what I'm going to do is I'm going to bring this down and start to do some pretty aggressive style compression on it. And so this is in the dynamics device. So you can see that we actually do get some kind of a saturation or a distortion characteristic. Overtones are being brought back in, and this is on the dynamics device. And this is an incredibly clean sounding compressor, one of the cleanest ones I've ever heard, and yet still you can see this makeup here when we do start to apply some compression. This is like that saturation characteristic, and it will vary based on the signal that's brought into it. This is just a sine wave, and we can see if we start at 200, my guess is all of these points will be multiples. So 600, for example, 1K here. Again, if we just are kind of going up and doing the 200, 400, 600, 800, 1000, up to 1,400, right? This is following some kind of variation on the harmonic series. The same thing is going to be true for the compressor, but it's going to be different. It's going to be a lot more aggressive, okay? And that's really kind of the difference between these. And you can see not only how much more it spikes, and there's a lot less gain reduction going on here, but as I start to increase the ratio, you can see what happens there. Definitely a lot more prominent, and this is going to add a lot more weight to your actual sound. All right, and depending on then where your threshold is set, you can see that this actually changes. So the balance is changing, and this is actually then going to make a difference on the sound. You will be able to hear this when you put the same settings in and you gain match everything. You'll hear that this compressor, it has a lot more weight. It sounds a lot more quote unquote musical, and this is kind of the reason for it. The dynamics is very clean, very digital. I actually really love it for the style of music I make, but the compressor is great when you need to add a little bit extra weight to signals. So whether that be your full track, whether that be what you have going on up here, with just a drum loop or whatever, even if it's just a single signal, this is really important. And we will be able to listen to this in just a little while. For the sake of comparison, I'll show you a couple more compressors, some plugins, and the overtones that those generate. Here we have the Kotelnikov, which is considered a feedback compressor. And when I think feedback compressors in the digital domain inside of the computer, I really just think of something that sounds, for lack of a better term, more musical, because if you'll notice, this attack time can go all the way down to 0.02 milliseconds. That is not something this compressor can do. It only goes down to 0.2. And obviously, as we start to go really, really fast, you start to see how a few more little overtones pop up. But this is nowhere near what we were just looking at least the balance of these that we saw with the compressor. This one's more transparent. We're doing a ton of gain reduction here. And as I go in here and put it back up closer to 0.2, just to match things to be fair, you can see a lot more transparent, a lot fewer overtones, and the balance of those is a lot less as well. So for me, this one works out really great. We can increase the ratio here, and you can see that we're not getting a whole lot of change. We do have to add a little bit of makeup gain to make this fair. But again, you can see and you could compare and contrast the differences here with something like this that's designed to be super clean. And even so, it's not quite as clean as what we were just looking at with the dynamics. But in that case, I think this one, the more musical nature of it, the way it reacts to the signal and that feedback design actually works out quite a bit better. And when you can set this one up then very quickly in more of a parallel configuration, we should be able to see that balance changing even more as we go back on the makeup, right? So we can do something like that and try to even decrease that balance further. So to make kind of a drastic comparison, I've brought in this Disto plugin, which is more or less an emulation of Empirical Labs Distressor. And we'll see what happens when we start to bring in some compression here. So I'm going to start to increase my gain. You can see we're getting some gain reduction here. This is the maximum we can do at this point. I could obviously go in and increase the ratio, but this is good enough. So we're getting roughly 7 dB of gain. We can compensate a little bit here, bring the volume up. In fact, it's brought the volume up quite a bit here. So something like this is probably fair. And this doesn't seem too drastic at this point, but do be aware that we are in clean mode. And then we can also go in and do some further things. We can add in a hottitude setting and then also a warmth. We'll begin by bringing in our transformers. When we bring in our transformers, you can see that has changed this balance slightly, but in terms of the sound, you might be able to hear a big difference. We can then go in and add some additional hottitude to this, and you can see how drastic this has changed things. And then we could also go in and add what they call some warmth. So this is all just a distortion characteristic. Find something here kind of in the middle. And then to even amp things up further, we have these additional drive controls. So I can go in and I can do something like this, and you can see just how much this is impacting the signal and the sort of different saturation amounts that are being applied using this compressor. Obviously, this is us using it, you know, kind of in like an out of order setting, but this is actually considered the clean mode. We could go in here to out of order and notice how with out of order, what it actually does is it decreases the amount of harmonics, but the harmonics that are being brought in are not going to necessarily be related. So it may not follow the harmonic series like you would expect it to. And so this is kind of an odd balance here. And also, interestingly enough, the warmth isn't really working at this setting. So we have to kind of like change some things around. Very, very cool. So much variation in a plugin like this. And the whole point that I'm trying to get across to you is, you know, just looking at it here isn't going to do a whole lot for you. You're going to have to listen to it, try to dial these settings in yourself, and then find what works the best. So the last thing we'll do is we'll just compare the sound on the Dynamics device to that of the compressor and try to hear how the compressor, with its saturation characteristic, gives you a bit more punch, a bit more weight to the overall sound. So the final thing we'll do is just a basic compare and contrast. I have the settings to be basically identical, and so you will be able to now hear the difference between the two. I'm not going to say anything during this playback. I don't want to bias you one way or the other, but be very cognizant of, number one, the perceived weight that's added, number two, what happens with the low end, and number three, what's going on with the transients. So these are both at -20 for the threshold. Okay, and I can just show you this so you believe me. The ratios are both at 4. The attack is at 1, and the release is at roughly 104. We have the same thing set up here. Okay, and then I've gone in and I've done the proper gain staging to make sure that the output is always going to be the same. So we'll start with the original just so you can get that in your ear. Not very important actually, but... So I've done this comparison before, and I think with a signal like this, the difference is really night and day. It's very obvious that you hear something very different going on with the dynamics versus the compressor. And so it's about finding the right place for these different processes. And just remember, there are times where going in and drawing it in yourself honestly gets you where you want to be the quickest. But then there's other times when you want to experiment with some of the different dynamics effects that might speed things up, and so forth. So the last thing I'll say is that something like the compressor, in my opinion, it doesn't sound particularly good on like spoken vocals. So if I was to record something like my own voice, I would always use the dynamics as compared to the compressor. And I think after you've maybe gone through and watched this video and you saw what happens with the saturation curves, you'd understand why. But when you have something like a drum loop, yeah, man, this compressor definitely makes that thing pop and bounce a little bit more. So thank you so much for your attention. I hope you've learned something new. If you have any questions, please do not hesitate to ask. Until next time, take it easy.